All right, if we're going to write names from formulas, all we do is we name the cation the way we've been doing it. If it's a fixed charge metal, we just name it as the metal name. If it's a variable charge metal, we name it as the metal name with the Roman numeral. We sometimes have to do some reverse engineering to get that Roman numeral. Then if we're going to name the anion, we're going to change the ending of that nonmetal to IDE. All right, so if we're going to name these, iron in the first one is a variable charge metal. So we're going to have to figure out what its charge is. Looks like we can just reverse engineer the crisscross, bring the 2 up as the 2- charge on oxygen and bring the 3 up, make that a 3+ charge on the iron. This works because oxygen actually is 2-. The fixed charge thing, we just by reverse engineering got the right charge, so we can be confident that the iron in this compound is 3+. So we're going to name the compound as iron, Roman numeral 3, oxide. First element, normal name, plus Roman numeral since it's a variable charge metal. Second element, IDE ending, so oxygen becomes oxide. In this next one, FeO, if we try to reverse engineer the subscripts, we end up with a charge of 1- on oxide, and we know that's not true. Oxide has to be 2-, so we're going to have to work this out a little more carefully. Oxide, we know is 2-. To cancel that out, the iron has to be 2+. And so when we go to name this, this is going to be iron, Roman numeral 2, oxide. This is one that if we go the other direction and try to write the formula from the name and we accidentally crisscross, we're going to have to recognize, oh, this has to reduce to FeO. All right, on the next one, we have TiO2. Titanium's a variable charge metal, so we are going to have to figure out what Roman numeral to put in for titanium. The oxygen part we're just going to call oxide, and we know that oxygen has a 2- charge, and this formula has 2 oxygens. So we have 2 ions that each have a -2, so 2 times -2 gives us a -4 total. Or we always write charges as or we're supposed to write charges as the number first, then the sign. So 4 negatives. That means that the titanium has to have 4 positives, and all 4 of those positives are concentrated on just a single titanium ion. So the charge on that titanium is 4+, so we'll write a Roman numeral 4. Then we've got calcium chloride, or calcium and chlorine. Calcium is a fixed charge metal, so it's just going to be calcium. And then the chlorine, we change the ending to IDE, it becomes chloride. In this next one, the oxygen is going to have to cancel out what the chromium brings, and we know that oxygen has a 2- charge. We have 3 of them, so the 2 negatives times 3 give us 6 negatives. That 6 negative has to be balanced by the chromium, so that'll make chromium 6 positive, and so this is going to be chromium Roman numeral 6 oxide. And then last but not least, sodium and phosphorus. Sodium is a fixed charge metal, so we just name it sodium. We don't need a Roman numeral on it. And then phosphorus, we want to change the ending to IDE, and so this becomes sodium phosphide. One last slide to kind of wrap up this process. These 3 examples give us some ions and ask us to write both the names and the formulas of the compounds formed by those ions. Let's start with the names because I think that's a little bit quicker. We just name the first ion, the cation, and then we name the anion. The cation, tungsten 4, is literally just called tungsten 4, so I'm going to write that in here. Whoops, tungsten. Roman numeral 4. The anion formed by oxygen is called oxide. The second one, we change the ending to IDE. On the next one, aluminum and sulfur. Aluminum is fixed charge, so we just call it aluminum, or aluminium if you're in just about any other English-speaking country. Sulfur, we're going to change the ending to IDE, so this becomes sulfide. So the compound's name is aluminum sulfide. And the last one, sodium and nitrogen. Sodium is fixed charge, so we just call it sodium. And nitrogen we change to IDE at the end, so that becomes sodium nitride. So those are the three names. We are also asked to do the formulas. Let's see, I'll do the first formula up top. Give me a little room to work. It says tungsten 4. So that means that tungsten has a charge of 4+. And then we have oxygen. Oxygen's a chalcogen. The chalcogens are all 2-. 4 positives and 2 minuses don't cancel out, so we're going to crisscross. We'll get a 4 as a subscript on oxygen, and we'll bring the 2 down on tungsten. But 4 and 2 can be reduced. They can both be divided by 2, so in the end we end up with WO2. For the second one, aluminum and sulfur. Aluminum is fixed charge. It's in group 13, so its charge is 3+. Sulfur is a chalcogen, so its charge is 2-. We're going to crisscross these, and we're going to end up with Al2S3. And last but not least, the compound formed by sodium and nitrogen. Sodium is a fixed charge metal with 1 positive. Nitrogen is in group number 15. Everybody in group 15 goes 3-. So we can crisscross this, and we'll end up with Na3N for our formula. Hopefully that helps you work through the process of ionic nomenclature. You do need to identify the metal as being fixed charge or variable charge. If it's variable charge, you need a Roman numeral. If it's fixed charge, we don't use a Roman numeral.